wherever it was. If you think I remember where it was. Oh God, okay. So should I do it again? It was M something, I forgot what it was. Let's see if I can actually reproduce it. No, not this one. Not this one. Not this one. Okay, this was. Good job. What? So GG comma 1 is big dimension GG. Now? So what did I do? I destroyed it? Yeah. Really? Why didn't you tell me? Alright, so we will simulate it again. Let's see if I can actually find it. Right. Good job, yeah. Linear model, GG comma 4 versus GG comma 1 plus GG comma 2 plus GG comma 3. And I want to do a summary. So I will take this guy and copy paste it here. Oh, here we go. Okay? Well, I'll do this exercise and I'll let you go to your coveted break. Don't worry about it. You know, it's okay. Questions? Right. So what I want to find this. So what is going to be my formula? My formula is my magic formula. So first of all, how do I find the residual standard? I need to find the residual standard error. How do I find the residual standard error? The formula is, in a compact form, is a variance of y minus beta covariance of f beta transpose. What is this? Remember what is this? This is a matrix multiplication. So, beta is a vector of beta 1, beta 2, beta 3. Okay? Right? So then, what you have here, you have beta 1, the vector beta 1, beta 2, beta 3, times your matrix, right? Your covariance matrix, which was, I think, what was it? For crying out loud. It was, I think, 0.2, 0.3, and 0.4, and zeros here, right? And then beta 1, beta 2, and beta 3. Now, the bad news is that in 2021 they did manually. I banned, right? I banned the computers. So they calculated all these manually, you know, with their calculators. But in your case, right, where I actually progress a little bit, you guys will do it using R, okay? You don't need to do it manually, you just need to do it using R, okay? So, I think it was M, right? So what you want to do, you want to take, I think it was C, the vector C, 1, 2, 1, 3, 3, 3, 3, 3, then 0.8, right? Percentage star, percentage, and now you look at M, 1, 3, 1, 3, okay? Percentage star, percentage, and here you take the T of your coefficients. like this. What? Once again, God, it should be our bind property. Like this. And here you want to have P of our bind. Like this. Oh, great stuff. Okay? What is our bind doing? Do you understand? Our bind creates a matrix. So if you look just on this is going to be a raw matrix of the coefficients. When you do this, it will create the column vector. This is exactly this formula. Where is it? Here. Where's the formula? Oh yeah, no, not here. This is the one-dimensional case. So it's going to be variance of y minus beta f minus beta covariance f beta transpose. So that's going to be the variance of epsilon. How do I get the square? How do I get the standard deviation? How do I get the standard deviation? I don't like this at all. Okay. How do I get the standard deviation? I take the square root, right? Okay, and now, what do I need to do in order to get the solve? What I do, right, I take solve m 1, 3 to 1, 3. I multiply by this guy. Oh, I need to, oh my God, I forgot, right? I forgot to subtract, and you didn't tell me. Shame on you. So I have this R bind, and I need to take the variance of y. So what is the variance of y? I said the variance of y is 2 or something, right? What was the variance of y? The variance of y was 2 minus this. And now you take the square root. Voila. So it's exactly this formula, and if you want to find the sigma epsilon, right, you need to take the square root of the variance of epsilon. Compare this to the theoretical result of R, pretty close. Is this clear? Is this clear? Is this clear? Questions? You don't need to simulate for this. You can just use the formulas. Okay? You can see that it's actually the standard deviations that is given you by the summary. So you have two alternatives. Either if you are too lazy, you can actually simulate. And if you don't want to be too lazy and just use the formulas, you get the correct result. And now comes the formula, right? For the covariances of betas, which is this one, covariance of F inverse times sigma epsilon squared divided by n. So what's the magic? I'm going to take my covariance. So it's going to be M 1, 3, 1, 3. And how do I invert it? Anybody? Wrong. So, very good. And now you do percentage star percentage, and you multiply it by what? By your residue. So by this guy. And you divide by the number of points. How many points I simulated? I think 10,000. 10,000. And what? Oh, I need just to multiply. Like this. Voila. This is your God's eye. This is, you see, right? The variances of beta 1, beta 2, and beta 3. And in this case, you immediately see that there are no dependencies between the betas because the covariance of betas are 0. So they are independent. Okay? So now, if I want to find the standard deviation of the first one is square root of this guy, right? For the first one. For the second one, you want to find this guy. And for the third one, you want to find this guy. And now you compare it with the simulation. So the first one was 0.014. Am I right here? Did I screw it up? How did I screw it up? This should be correct. This is very positive. This is the residual standard error, and I'm actually looking at this guy. This guy, and this guy. This is, I don't like 0.031. What is 1, 3? Okay, we will, let me think about it, because I don't like what I see here. I don't like the fact that it's not coincides. Here it's very good, but here I don't like the fact that it's not coinciding. But this is the correct formula, so who knows? Okay, we'll look into that in a moment. Okay? All right. It's 8:30 now, take your break.